we start a new topic called recursion. Now, what is this? Recursion. See, you call a function. Say there is a function, say factorial. That function factorial has got a certain prototype. Now, that factorial function you call from main. Suppose you have main, and from within the main, within this main, you call this factorial function somewhere, maybe over here you call, say, the factorial function. Now, when you call this factorial function, the factorial function gets called somewhere or the other. You close this main and say this factorial function gets called. This factorial function returns something which you receive over here. That is the flow of a function call. What is recursion? Recursion is calling a function from within itself. That is, question is, can the fact function call itself? Can the fact function call itself? That is the question. So fact function, if it can call itself, then you say that okay, that is recursion. But then if it calls itself, then there must be an endpoint. Because say, for example, you treat like this. Say this is the fact this is the fact function. You call the fact from within itself. Then what happens is, this fact is called, this fact calls fact. Again this fact calls fact. Again this fact calls fact. And this fact calls fact. It will never end. But again you remember that when we go in a loop, loop has also got an endpoint. Like that, recursive function calls, I use the term recursion, so recursive function calls will also have an endpoint. How? It goes like a recurrence relation. I am sure that all of you have heard of recurrence relation. And what is it? Say, in recurrence relation, to calculate the value of a function n, you take the help of, it may be anything, but also you take the help of function fn minus 1, and other computations are there over there. But then there has to be an endpoint, that is f1 needs to be defined. If you define f1, then the job is done. I think you understand this. So say f5 has to be computed. For computing f5, you take the help of f4. So to calculate f4, you will take the help of f3. Then to calculate f3, you will take the help of f2. For f2, you will have to take the help of f1. Now f1 is separately defined. So once f1 is calculated, from there you can now calculate f2. Then you can calculate f3 from there. Then f4 from there, and then f5 from there. That is what a recurrence relation is. So in terms of a recurrence relation, if you ever think of, then fact is a function, and if you want to calculate fact n, then all of you know that in terms of a recurrence relation, fact n is n into fact n minus 1. N factorial is n into n minus 1 factorial. That is 5 factorial is 5 into 4 factorial, is not it so? 5 factorial, that is equal to 5 into 4 factorial, is not it so? But then you may say, what is 4 factorial? 4 factorial is 4 into 3 factorial. Again you may ask, what is 3 factorial? 3 factorial is 3 into 2 factorial. If you ask what is 2 factorial, it is 2 into 1 factorial. And we all know that 1 factorial is separately defined as 1. So like fn is defined as n into f of n minus 1 or factorial of n minus 1, fact 1 is separately defined as 1. Is not it so? Fact 1 is separately defined as 1. which means that if fact 1 is 1, then here you can replace it by 1. If that is so, then this becomes 2. If this is 2, then in place of 2 factorial you may say 2, and 3 into 2 is 6. And if 3 factorial is 6, then in place of 3 factorial you can write 6, which is 24. Then again this 24, in place of this 4 factorial, which is 24, you may write 24. And then 5 into 24 is 120. Is not it so? This is calculation in terms of recurrence relation. So like fact 10 in terms of a recurrence relation is n into fact n minus 1, similarly fact 1 has to be defined as how much? As 1. That is a recurrence relation. Now keep only this recurrence relation in your mind. Fact 10 is n into fact n minus 1 and fact 1 is 1. Using this, a recursive program can be written. Please understand what? Fact. See, just follow the recurrence relation and write the program. Now, this recurrence relation will help you to write a recursive program. And for writing a recursive program, you don't need to think of logic that we think for when we do using a for loop or a while loop or anything. That logic will automatically be built in the recurrence relation which we will follow. See fact n. So here fact will receive, fact is a function which will receive int n. See this, fact n. So fact n, fact will receive int n. So what does the function say? It says that fact n is n into fact n minus 1, but fact of 1 is 1. So if this n is 1, then the answer is 1. That is what it says, that if this n is 1, then the answer is 1. If this n is 1, answer is 1. Else the answer is n into fact n minus 1. So let me write the program exactly like this, that if n is equal to 1, if n is equal to 1, then the answer is 1. That is, you return 1. That is, you return 1 then. If n is equal to 1, you return 1. That is the answer that is expected from you. Because fact function has been called. Int n, fact function has been called. So, it is expected that you will return the answer. So, if this n is 1, the n that has been sent, if this n is 1, then your job is to return 1 because fact of 1 is 1. Else what is the answer that you will return? The answer that you return is return, see what? N into, you follow the recurrence relation. The recurrence relation says return n into fact n minus 1. It says that your job is done over here. You are returning an integer, 1 or the answer, so the return type is int. And this much, writing this much will be done. Your program is done if you write only this much. See how it happens? It says your recurrence relation was this, fact n is n into fact n minus 1 and fact 1 is 1. So you have done exactly that. You receive this n. So if n is 1, you return 1. That is what it says. If n is 1, you return 1. So if n is 1, you return 1. Else your answer is n into fact n minus 1. So else you return the answer n into fact n minus 1. Your program will start working. Now you may think that what logic is this following? Will it work? What logic is this following? You please see whether this runs or not. So let me just do printf %d, just to keep it simple at the moment, %d. You call the fact function, sending it 5. See, you are calling the fact function. Here you are basically calling the fact function, sending it 5. So here 5 you are sending. You are expecting that it will return 120 and this printf %d will return this 120 for you. Is not it so? So this program should run absolutely fine if this function is correct. So let me comment out this whole thing and see whether this program that you have written, this function that you had written using recurrence relation, the recursive function that you have written using recurrence relation works properly or not. Let me run it. I save it first. I run it now. It should print 120. See, it prints 120. I've just run it, it prints 120. Instead of this, you send it fact 6. It should print 720. Should not it print 720? Run it. 720. Run it with 7. 720 into 7, 5040. Runs absolutely fine. For 8 it should not work because 8 should be 40,000 something. But problem is 40,000 is more than the range of int. Int is up to 32,767. So this will not give you a proper answer. But if you can now make it long int, if this return type, you just make it long int, then this should work fine. This return that you are calculating should work fine. You are just defining it as long int and maybe printing it as long int. It should work fine. Let me run and see. Yes, now it runs fine. Even if you do it for 10, it will run fine. Sorry. If you do it for 10, then also it will run absolutely fine. So do you understand this? But you see that the program is running, but you don't know how it is running. I will try to explain you firstly using this editor only. Then I will try to explain you using a diagram. See, first and foremost, you think like this. Suppose 5 was sent to it. How it works? 5 comes over here. Now this n is 5. Now n is not 1. So it does not enter this. It enters this. You are saying return 5 into fact 4. So see, this return is not happening firstly. Because this return cannot happen until this whole thing, n into fact n minus 1, this whole thing is computed. Return cannot be possible. But then again, multiplication is also not possible because firstly this fact n minus 1 has to be computed. So this n4, fact 4 is again called. Now this fact is again called with n equal to 4. So if n equal to 1 is again skipped, it comes over here. It says return 4 into fact 3. Return not possible. Multiplication also not possible. But calling of fact 3 is possible. So fact 3. N with 3 comes over here. Now n is 3. If n equal to 1 skips, enters the else block. So return 3 into fact 2. Return not possible. Into also not possible. But calling of fact 2 has to be done first. So fact 2. So n is 2 now. If n equal to 1 is skipped, else part. So now return 2 into fact 1. So here it comes with n equal to 1. If n equal to 1, return 1. Where does it return? It returns here. It returns 1 over here. But see, when it returns, the value of n over here is 2. Because remember, when it called fact 1, n was 2. Because n was 2, you called fact 1. So when it returns, n is 2 and it has returned 1. So 2 into 1 computed and it says return 2. Where does it return? It returns to the point from where it was called. From where it was called? From here only. So the 2 is returned here only. Now it says n into 2. What is this n? N is 3 this time. Because when it called with n equal to 2, n was 3. So 3 into 2, 6 computed, returned. Returned here only. When it returns 6, n is 4. Because 3 calculates 6, 3 factorial is 6. So 3 was calculated. When you send 3, it returned 6. So n is 4 over here. 4 into 6 is 24. Now 24 is returned. So when 24 is returned, n is 5. 5 into 4 is 120. Return 120. Where does it return? to main, because n was 5, n5 was called from main, so 120 is returned to main and it prints 120. Not quite clear, but what I will do is I will try to explain this to you with a diagram through which the whole thing will be absolutely clear, because you understand that this program is working. Only question is how it works. Writing a recursive program is easy because you don't need to think of logic. You only need to follow the recurrence relation and just put it in a code format. Here the recurrence relation was fact 10 is n into fact 10 minus 1, fact 1 is 1. So you just formed it a code. If n equal to 1, return 1, else return n into fact 10 minus 1. You never thought of the logic how it works, but internally through some logic it is working. How it is working, that is the explanation. But writing a recursive function is not tough. We will come back with more recursive function after this small explanation through a diagram. So I will quit this program initially, and now I will go to a Word file where I will show you through a diagram. Follow this diagram very carefully. See what I am trying to do. Let me write this function that I had written. Long int fact, you receive an int n, and then you just write 2 lines of code. That is, if n is equal to 1, you return 1. Else you return, what do you return? Else return n into fact n minus 1. That is what you have written. Now let me just quickly get rid of this auto corrections of capital things to small things to capital things. It's not needed, it disturbs. This if is not capital, make it small. So this is the program you have written. This else is also small, otherwise this is absolutely fine. So this is the program you had written. Now how this program works? For that, I also say main is there. From this main, you have called this fact maybe with 5. Just an example. Get rid again of the auto corrections of small to capital. It's not needed, it disturbs. So this is the thing. Fact 5 has been called. So it comes with n equal to 5. Please understand, I just increased the font a little bit for the things to be easier. See, fact 5, it calls fact 5 over here. So here fact has been called with n value equal to 5. How I try to explain you with an example is, I will draw something. I insert a shape of a circle. Here, when you say this is the fact function which has been called from main, and it has been called from main with a value of n is equal to 5, not capital N but small n. It has been called from main with a value of n equal to 5. So called from main means you may think that here it has been called from main like this. So what is over here? Here there is main. I insert a text box and write main over there. Sorry. Here I delete this thing and I write main. So main function has called this. So this main say is over here, which has called this fact function with n equal to 5. Please understand this. Here the main function has called this fact function, which I have represented using a circle, with n equal to 5. See how it works. You will understand, and this thing is so interesting. So this main function has called this fact function with n equal to 5, as you can understand from the diagram. Now what is the function doing? You see, function has been called with n equal to 5. So here you are with n equal to 5. You are here with n equal to 5. Now if n equal to 1, false. So else. Return, not possible because multiplication needed first. Multiplication not possible because fact n minus 1 is called. So do you understand? Now fact 4 is called. So you think like this, a new environment is created. I repeat, a new environment is now created with the call of fact function again, but this time with n equal to 4. Now who has called this, created this new environment? Who has called the main fact function again? This fact function. This environment you check, n equal to 5, where n equal to 5 has called fact function again or created a new environment where n is equal to 4. So this has called this. I again insert a arrow indicating that n equal to 5, this environment has called for n equal to 4, this new environment of fact. Main is a function, it is one environment, it is still living. This environment has called this, it is still waiting for the return, it is living. It is living and waiting for a return from this environment. This environment n equal to 5 has been created for the fact function. Here n is 5. If n equal to 1 is false, so this does not happen. Else part. Return waits for the multiplication. So multiplication waits for the fact n minus 1 called. So again fact n is called and n equal to 4 is passed to it. So over here n is 4, this environment is created where n is 4. But this environment is living and waiting for the control to return. The control will return from here, but it is waiting for the return. But this environment is living and active now with n equal to 4. You understand? So if n equal to 1 is false, else part, return, yes it will return, but firstly multiplication needed. Multiplication first needs this function call again. So again fact function is called with n minus 1, that is this fact function will be re-invoked with n equal to 3. So what do you understand? A new environment will be created with n equal to 3. Here it is. With n equal to 3, a new environment is now created. Here n is equal to 3. But this environment is living but not active, inactive, because this has invoked this new environment where n is equal to 3. This environment is living and active. N equal to 3 over here. N equal to 1 is false, else part. Return, yes it will work, but firstly multiplication. Multiplication will work, but firstly fact n minus 1 called. So again, fact 2. Fact has been called with n equal to 2. So again a new environment is again created. With how much? This time with n equal to 2. So this environment where n was 3 has invoked this new environment where n is not 3 but 2. I will just make this 2. This environment is living but inactive. All these environments are living but inactive. Main had called this. This has called this. This has called this. This has called this. So n is equal to 2. This environment is living and active. So n equal to 2. If is false again. So else. Return will happen but firstly multiplication. Multiplication will happen but firstly this function call of fact n minus 1. N is 2. So it is calling fact again with n equal to 1. So here the control is in a new environment with n equal to 1. So this is the new environment with n equal to 1. Here it is with n equal to 1. So see this. This is the new environment called now with n equal to 1. Remember, all these environments are living but inactive because this environment is active now where n equal to 1 is called. But all these environments are there and there the values of n are like this. This is a new environment with n equal to 1. Remember, in functions, all variables in a function are redefined. So the n of main has got no relation of the n of fact. If you change any n in fact, then the n of main does not change. Similarly over here, if n is changed, n equal to 1 is changed, this n equal to 2 does not change, because this n equal to 1 is of the current fact function which is working. This n equal to 2 was of the previous fact function which was active. This is now active. So n equal to 1 here. Now see what happens. N is 1. If n equal to 1 is true now, it says return 1. It says return 1. So what will it do? It will now return. It will return. If it returns, where does it return? From this environment, it returns to this environment. With what value is it returning? It is returning 1 value. So this environment is returning. Where will it return? To the environment which called it. This will not return to main, because main did not call this environment. This environment was called from here. This fact function was called from this fact function. So the return from this fact function will return here only. And what value is it returning? It is returning a value of 1. Let me write it in the text box. Let me write 1. 1 is the value it is returning. Let me just take this like this. Sorry. So this 1 is being returned. We check this. This is returning 1 to this environment. In this environment, what is n? N is 2. What is the value it is returning? 1. Now this environment is dead now, because it is no more living. It has returned means this fact function is over. Once a function is returned from a function you return, it is over. So this function is dead now. It has now sent it to this function which is both living and active. But where does the control return? To the point from where it was called. From where was it called? It was called from here, remember? Is not it so? It was called from here. So this value of 1 is returned over here only. Here it is 1. So n into 1. N into 1. What is n? N in this environment is 2. So 2 into 1 is 2. Return 2. What is being executed? Return 2. This is 1 over here, but this return control has returned to this environment. In this environment, it has returned to which point? To this point, because this was the point from where it was called. So n into fact n minus 1, n into 1. So here n is how much? In this environment, 2. So 2 into 1. What is being executed right now? Return 2. So here it is executing return 2. So don't you understand? Here again a return is being executed. Here a return is again being executed, and this is returning how much? It is returning 2. See this, it is returning a value not 1 but 2. So here it is returning 2. So 2 is being returned to this environment. Now this environment, in this environment, what is n? N is equal to 3. So n into fact n minus 1. So here this 2 is returning to that environment, okay. But the control is present where? The point where it was called from. It was called from here. So this 2 is present over here. N into 2. N in this environment is 3. 3 into 2 is how much? 6. So what is it returning? It is returning 6. So this environment now executes return 6, because n is 3. 2 has been returned here. So 2 returned here means this n is 3. 3 into 2 is 6. So return 6 is being executed. So return 6 means over here return 6 is executed. So let me again just bring this and say now 6 is being returned. Check this. So 6 is being returned. Here it is returning 6. So this 6 has been returned to which control? This environment. Now in this environment, control is present where? Control is present here. 6 has been returned to the point from where it was called. So 6 has been returned here. Is not it so? So n is how much in this environment? N is 4. So 4 into 6 is being computed. So return how much? Return 4 into 6. That is return 24. So this environment is now executing return 24. Is not it so? So here, check this. It is executing return 24. How? I will explain again. 6 was returned over here. 6 was returned to the point from where it was called. So this point 6 was returned. N is how much in this environment? 4. So 4 into 6 is how much? 24. So return 24. Here return 24 is being executed. Remember, return 24 is being executed. Is not it so? I'll just make it smaller. Okay, so return 24 has been executed. But check, this 24 again has been returned to which point? Exactly the point from where it was called. So 24 was called from this point. So 24 is present here. Now n into 24. N is how much in this environment? N is 5. So 5 into 24 is being executed. Return 5 into 24 is being executed. That is return 120 is being executed. So this environment will return where? To main. How much will it return? It will return 120. So let me now show you that 120 is being returned to where? To main. To main, how much did it return? It returned 120. Why is it returning 120? Because factorial of 5 is 120 itself. So this 120 is being returned to main. So main is receiving how much? Main is receiving 120. I'll just make it smaller to get you understand this whole thing. Once more I will explain. So this is, I made smaller a little bit so that you understand. This 120 is returned where? Exactly to main. Do you understand this? Do you understand? So factorial of 5 is 120. Remember, main passed 5 to it. So main is getting back 125 factorial. How it worked? Main called with n equal to 5. Once more, explanation once more. Main called this with n equal to 5. With n equal to 5. So in this environment, n is 5. If part is false. Else part return into all possible after calling fact n minus 1. So this environment invokes another environment with n equal to 4. But this new environment n equal to 4 has got nothing to do with this n equal to 5. The change of n over here will not change the n of this, because the mains n does not get affected if you change the n of fact. Similarly, the new fact change of n will not change the n of the previous fact function. So this environment is there with n equal to 5. In this new environment, n is 4. So if part is false, else part return n into fact n minus 1. That is 4 into fact 3. So everything possible, firstly fact 3 is called. New environment is now created with n equal to 3. This n equal to 3 has got no role to play this n, because this n is of the previous fact environment. So all these environments are leaving but inactive. Which one is active now? N equal to 3. If part false, else part true. So return multiplication everything possible after calling fact 2. New environment with n equal to 2 is created. New fact function is called. N is equal to 2 there. So n is 2. So if part is false, else part, return n into fact n minus 1. So this return not possible, multiplication not possible. Fact n minus 1, that is fact 1 is called. So fact 1 is called means n is equal to 1 over here. New environment created. If n equal to 1 is true, return 1, true, 1 is returned over here. This environment is dead now, not living. This is now living and active. These are all living and inactive. So this is now active. 1 is returned. Where is 1 returned? From the point where it was called. It was called here. So here 1 is returned. So firstly n into 1 will be computed. How much is n in this environment? 2. So 2 into 1. Return 2 into 1. That is, it is executing. This environment is executing. Return 2 into 1. That is, it is returning 2. So 2 is returned to this environment. To which point? From the point where it was called. So it was called from here. So 2 is returned here. So n into 2. N is 3 in this environment. So 3 into 2 is 6. So 6 is returned over here. You understand? 6 is returned to this environment. These environments are dead because you have returned. Only this are living, and this is living and active. These are living and inactive. So n equal to 4, 6 is returned over here. So n is 4. So 6 is returned to this point. So n is 4. 4 into 6 is 24. Return 24 is executed. So return 24 returns 24 to this environment. This environment is dead. These are all dead. Only this is living and active, and this is living and inactive. 24 returned to which point? From where it was called? It was called from here. So 24 returned here. So n is 5 in this environment. 5 into 24, how much? 5 into 24 is 120. So 120, return 120 is being executed. So where will it return? It was called from main. So 120 will be returned to main. So main, which point? From the point where it was called. It was called from here. So 120 is there. It is returned. So do you understand how this entire thing works? I will go back to C. I will go back to C and again show you this program. So see, this is the program which you had executed with fact 5. If you run it once more, yes, it is 120. If you run it with 6, it will still show 720. If you run it with say 10, it will still show the factorial of 10, which is 3628800. So I think you understand this. This is how you write a factorial function. I will just show you very quickly another recurrence relation and convert it to a recursion program, which you can again execute or understand the execution using that same diagram. Say if you are asked for calculating power of a comma n, that is a to the power of n. Please understand, power of a comma n is a to the power of n. How do you calculate that? You know a to the power of n is nothing but a into a to the power of n minus 1. Please understand, is not so. What is a to the power of n? A to the power of n is nothing but a into a to the power of n minus 1. So I have written exactly that. Power of a n is a into power of a n minus 1. But there has to be an end point. What is the end point? The end point is power of a1. What is that? That is a. Or you can say the end point is a to the power of 0 is 1. That also you can say. Either power of a0 is 1 or power of a1 is a. Anything will work fine. So in this way it will work. See, a to the power of 3. A to the power of 3 is a into a to the power of 2. A to the power of 2 is a into a to the power of 1. A to the power of 1 is a into a to the power of 0. A to the power of 0 you are defining as 1. So a into 1 is a. So power of a to the power of 1 is a. In this way this whole thing can work. So if you have to write a power function using the same recursion, cannot you just copy from the recurrence relation? See, what does the recurrence relation say? Long int pow, it will receive a comma n. See, pow a comma n. So just to convert it to a recursive function, you can say long int pow should receive int a and int n. And here, if n is 0, see, check this. If a to the power of 0 is 1, so if this n is 0, check this, if this n is 0, then your return should be 1. So exactly this, if n is 0, your return is 1. If this n is 0, your return is 1. Else your return is a into power n minus 1. So else your return is a into pow what? A comma n minus 1. So see, I have just converted this recurrence relation to a recursive program without any thought of logic. The logic I did not need to compute myself, because I know this is the recurrence relation. I just have written this program. If n is 0, return 1. So this is this. You look at this. You have received pow a n. So long int pow int a int n. Pow a n. So long int pow int a int n. Here if n is 0, you return 1. So if n is 0, you return 1. Else if n is not 0, then you return what? Then you return a into power a n minus 1. So return a into power a n minus 1. So you just calculate this, write %ld, calculate pow, say 3 to the power of 4. What is 3 to the power of 4? 3 into 3 into 3 into 3, that is 81. Is not it so? Let me run it. Okay, sorry. Firstly, you need to make this thing within the comment. Is not it so? This must be commented out. Now if you run it, then 3 to the power of 4 should print 81. See, 81 is printed. Is not it so? Calculate for something else. 4 to the power of 6 maybe, or 4 to the power of 5. 4 to the power of 5. That is 4 into 4 is 16. 16 into 16 is 256. 256 into 4. What is that? 1024. Is not it so? So it is calculated. You can do simple things. 2 cube. 2 cube you know is 8. Run it. See, 2 cube is 8. So this program runs absolutely fine. You can again draw the diagram how recursive program works and check for yourself that how this program is internally working. You will be very interested to see how it works. Again, please take a piece of paper and try to draw the diagram of the entire flow. You will really be interested. It will be very exciting. Thank you so much. We will come back after a bit of break with 2 more recursive programs. Thank you so much.